Hello, welcome to our fourth episode of Azure Community M2S. So my name is Nicholas, and I'm with my co-host Kevin Green.
Hey, folks. Thanks for joining. Thanks,
So,
Nick. Looking forward to another night of learning some cool new stuff that you and I have never done before in
yeah.
some cases.
So on this today's session, we're gonna do on. So so this is our fourth episode. So how you can stay up to date on what latest up on our meetup. So you can follow us on LinkedIn, Twitter, YouTube, and Facebook, and you can scan the barcode as well. So this is our agenda for today. So it's the fourth episode, and it's going to be based on Azure Network and app configuration. So in roughly 5 or 4 minutes, there's Leo Visser from he's a cloud consultant. He's going to talk a session on spot Azure network problem by visualizing it.
And then up after Leo, we have Matteo Emily, who's a director, head of software engineering at Avanade UK and Ireland. And Matteo is going to talk about easy feature flags with Azure app configuration. So
Yeah.
I'm really looking forward to both of these sessions. Thanks, guys, for joining.
Yeah. Okay. So on our next episode, there is going to be the 27th. A little mistake. We're gonna get Simon Lee. He's gonna do getting started with static web apps and some blogging, as well as another one from Johnny Hallberg, can I pronounce it properly? And he's doing deploy your cloud native .NET apps to Azure Container Apps. So that should be a fun one. So stay tuned for the next one. Let me bring. So the first episode, the first one we're going to be Leo Visser. I'm gonna put it on my screen. Remove that. Leo, do you want to share your screen, please?
Yes, I will. Um, 1 second, I need to, yeah. So, thanks for having me.
There you
Do
go.
you want to say anything more, or should I just start now?
Yeah, you can start. So yeah. So
Okay.
Leo is going to do a session on Spot Azure Network problem visualizing it. So he's going to give you some ways on how you can identify your network.
Yes.
Leo, we'll keep an eye on the chat for you. So, folks, anyone online who wants to ask a question, drop them into the chat. If we can't answer it from the chat, Leo will put some time aside towards the end of the session, and we can hopefully give you the answers that you're looking for then.
Yes, thank you very much. So, welcome to my talk about spotting Azure network problems by visualizing it. I've got a lot of stuff to talk about and not much time, so I'll try to keep all the questions to the end. Because hopefully most of the questions will be answered throughout this session anyways. So who am I? I'm a cloud consultant at OGD in the Netherlands. I do a lot with infrastructure as code, CI/CD, automation, DevOps, all the buzzwords you can think about. And I've been in the field for about 11 years now and worked myself up from a developer, did some things with applications, did some sysops, did some DevOps, and now I'm a consultant. You can find me on the socials, other sysops, and I've got a blog where I regularly or sometimes post new blog posts. I should do it more often. So what are we going to talk about today? First, we're going to dive a little bit into Azure networking, what Zero Trust is and how it works together with cloud networking. Then we're going to look a little bit at what's different with networking in the cloud there compared to on-premise networking. We're going to look at some common mistakes you will see when people are setting up Azure networks. Then we're going to look into flow logs and traffic analytics, which are techniques provided by Azure. And in the end, we're going to look at detecting the mistakes which can be configured and how you can actually spot them with these tools in Azure. So, zero trust. It's probably something a lot of you have heard about before. Zero trust is the thing all the security experts lately say we should do. So, zero trust, it has three big pillars in it. The first pillar says verify explicitly, which means that every time you do a request or whatever to a service, a server, something, you will always check the credentials of this request. So it's not you show your username and password once and after this you get access and just go every time you're verified again. The other big pillar of zero trust is to use least privilege access. So if you don't need the permissions, you don't get them. You only get what you need. And the last one is to assume breach. By assuming breach, we will look at our network in a more distrusting way. So instead of only protecting the outside of our network, we will also protect the inside of our network. We will assume there's always somebody inside our network trying to steal our data. So we need to make sure everything is secure, not only the outer perimeter of the network. So when bringing this to the cloud, there's a lot of interesting techniques we can use. And in some ways, it becomes a lot easier compared to on-premise networking, but in other ways, it becomes a lot more difficult. Because if we're looking to the verify explicitly, in the cloud, there's a lot of built-in authentication and authorization techniques. There's many things we can use in the cloud to make sure our authentication authorization goes a lot easier. But often we don't have an environment which is only cloud. We also have connections to on-premise systems. And we also need to make these connections to on-premise authentication services. For example, an Active Directory or whatever. Some people might still want to use LDAP or other services, and we need to make sure it works. Also, the least privileged access. When working in the cloud, we have a lot of granular permissions. Everyone who has ever looked to the Azure portal, to all the different kinds of permissions you can give somebody, will know that there's many different permissions and you can go even deeper with custom permission models. But on the other hand, there's also multiple different ways of assigning these permissions. It's getting better and better in Azure. But for example, not so long ago, if you had an Azure Key Vault, there was a different system to provide permissions to this. When using app registrations, there's like 2 or 3 different ways you at least you can give permissions to a user or an app or whatever. So we also need to make sure we understand all these different ways of providing permissions. And when assuming breach, when in the cloud, we have a very big attack surface because a lot of it is connected to the internet. We don't have our firewall with our internet connection coming in, and this is the point where people come in, so we just have to protect this. Now, it's somewhere in a data center we don't know, and it's connected in many different ways. So we have our pros and our cons, and working with zero trust in the cloud means that we need to think about our networks very carefully to make sure we don't make mistakes. And when talking about networks in the cloud, um, they are a bit different than networks on premise. On premise, we talk about switches, routers, some cables. In the cloud, it's all virtualized. People who've been working on premise in more advanced data centers will probably also work a lot already with software defined networks. And when going to the cloud, this is a less of a big step. But still, when working in the cloud, we don't have any physical infrastructure anymore. It's all virtual. And besides that, when we are looking at cloud computing and setting up services in the cloud, there's kind of two ways we can do it. We could say we have our different services, maybe virtual machines, maybe something else, and we could just connect them to the internet. We could go back to the easier days of the past where we didn't have like internal networks and so on and just gave everything a internet routable IP address and they could connect to each other. Not doesn't matter where they are. With the cloud, we can kind of do this again. We can give our resources in the cloud access to the public internet, and the public internet direct access to our services. And especially when working with platform as a service services, I always like how that works when pronouncing it. It's quite often that these are just connected to the internet. If you're using a key vault, often people will just access the key vault over the internet. A different way is to use private networks, use virtual networks we can set up in the cloud and make sure we do our routing over these networks and make sure that the services in our cloud platform connect to each other via this virtual network. So when we're talking about virtual networks in the cloud, there's a few principles we need to know. So we have our virtual network, which we will give an IP range. If you're not really into IP ranges or whatever, doesn't matter that much. We call it an address space. And what it says is just at which IP address do we start and at which IP address do we stop. And everything in between can be in this virtual network. If you're only setting up some virtual networks and that's it doesn't matter what you pick. But once you want to connect these virtual networks to each other, we do need to make sure they don't overlap. This connection of virtual networks is called peering. And with peering, we connect these virtual networks together. And in the virtual networks, we have DNS servers. I will get back to these in a moment because just like on premises, we also have subnets, and these subnets also have an address range. So again, which IP addresses can be found in this subnet. Now, just a while ago, Microsoft also announced that there will be some changes to how the default internet outbound rules will work on subnets and virtual networks. In the past, if you had your virtual network in a subnet and you connected a virtual machine to it, this virtual machine would have internet access by default. There are some rules in there to make sure the internet can be reached. This will eventually be changed. I don't know the date from the top of my head. I believe it's somewhere 2025, but maybe somebody can look this up and post it in the chat already for me. And one of the solutions for this is to use a NAT gateway. These are small things we can use to make sure that we can actually provide our subnet with access to the internet. And there's also network security groups, which are kind of like small firewalls we can use to protect our subnets. And I was talking about these PaaS services, these platform as a service services, for example, a key vault. They will have a connection to the internet by default, which we call a public endpoint. But they can also be connected to our virtual networks, to our subnets. And we do this by a private link. When making a private link, we create what we call a private endpoint for these services. And to be able to reach them, we would also need a private DNS zone. These DNS zones, they are connected to the DNS servers for these virtual networks so they can reach it. I'm not going to go too much into detail about these DNS servers and how this works. I can talk about DNS forever. People who know me a little bit, they know I can really do this. I like to bash a lot on DNS. So talking about the network security groups, because they are quite interesting. Network security groups are kind of small firewalls, very basic firewalls we can attach to a subnet, even to a network interface, and we can use them to manage what traffic will be allowed and what's not. So let's show you a little bit on how a network security group looks. So for example, in the Azure portal, I believe you can still see my screen. You should be. In the Azure portal, I can select a network security group, and this network security group will have certain rules. They will have inbound and outbound rules. There are some default rules, the 65000 and onward rules. They are default rules always added to our networks. And these are some rules I added myself. So let's take a different one, which might be a bit more clear. For example, this is a virtual of a network security group added to one of the servers. I'm going to explain later which server this is. And you see it has some outbound rules. I can click on a rule. I can see it as a source port range, a destination server stack or port range, depending on what I select. Port ranges protocol. People who are a bit into networking, what they use is the 5-tuple principle. So we have our source port, destination port, and protocol. And based on this, I can either give it an allow or a deny. And this way I can control the traffic for my resources. So the last one I want to go over before we go into the common mistakes is the application gateway. This is a tool used very commonly in Azure networking to make sure we get some outbound access. There's different ways to provide outbound access. On screen, I've added a little graph depending on if you want global or regional and HTTP or non-HTTP traffic. There's different things to do. In the past, you needed to know this from the top of your head. Nowadays, there's like a whole wizard in the Azure portal helping you pick the right one. So what these things can do is they kind of work as a reverse proxy. You can, from the internet, access them and they will provide the data from the internal network. So if you have a web server running in a virtual network, you can use an application gateway to publish this web server to the internet. And people can reach your web server via this application gateway. So this application gateway also allows for some security features. We call it a web application firewall. And this web application firewall, it can use a lot of different rules to make sure our traffic is safe. So let's go on to some common mistakes. So I've been working with Azure networking for quite some years now, and I've helped smaller and larger organizations to improve or set up their networks. And one of the things I find a lot when I first start at a new company is they say, yeah, we only use like private endpoints, everything is internally, and then you're gonna test some things and you try to reach the internal resource and you get some public IP address. You're like, that's not right. but I do get the results. So what's happening here? Or maybe they change some things and it's not working anymore. This is something I've seen happen many and many times again. So what's the cause? Well, it's always DNS. Like I said, I like to talk a lot about DNS. And often the case is they are using these private endpoints, but to make these private endpoints work, you also need the private DNS zone to be linked to the virtual network. And if this is not linked, then you will get the problem where it's still using the public DNS. If these machines also have a connection to the internet, which they often have because of the default behavior of Azure, they can just use the public DNS and still reach it because the internal and private DNS zone name they will be the same. If you use the private endpoint, the Azure DNS will make sure that it goes to the private connection. But if it can't find it, it will find it in the public one anyways. So to make sure this problem is solved, often it's just a matter of linking the private DNS zone to the right virtual network where these resources live that try to access it. Optionally, something I like to do is just removing the public endpoints completely. So at least then you know if something really is not working. I've seen many companies who are like, yeah, we kept these public endpoints open because, yeah, we're not using them anyways. And they create attack vectors by this. It's a place where people can try to attack your systems. So why not just remove them? And then when I propose this, it's like, yeah, maybe something is still using it. We're not quite sure. So just let's keep them. And yeah, then we can continue to talk about what I'm going to show you in a moment, how we can actually figure this out. Now, another problem I've seen quite often is, for example, we have some kind of database and the database admins, they come to me and they say, hey, we've seen some weird things in the logs. We've seen some things which looks like SQL injections. And I go to security and security is like, yeah, we've got like web application firewall, all kinds of protections in front of these applications. Shouldn't be possible. So maybe there's somebody from the internal network trying to reach these databases. If we go look a bit more, often what's happening is these applications, they're hosted in a Azure web app or something else, which has a public accessible IP or DNS name or whatever, and a private one. And the web application firewall is put in front of it, but the public IP address is not really disconnected or protected for any access. So somebody figured out this public IP address, and this way it can circumvent the web application firewall by still accessing the application and then using it to try to cause damage to the system. How to fix it? Well, for a lot of resources, you can use some kind of access control to block these public IP addresses, and you can again try to just remove them. Some things like web apps, I believe, are not able to work without some kind of public IP address, but there is access control in them to make sure that nobody else can access this IP address or this connection this way. And it can only be accessed via the virtual internal network, which then can be linked to our web application firewall, our application gateway. So this was a little bit about how the Azure networks work, just to give you an idea on what we're going to do now. Because, like I said, we want to assume breach. So we want to make sure that we're scanning our network. We want to make sure what's happening in our network. If anything weird is happening in our network, we want to see this. We want to get notified about it. So on-premise, we would set up some kind of security operations center. We would use port mirroring on switches or other systems to make sure all this traffic gets ingested in some kind of appliance, which will then scan it for us and give us reports. In Azure, we can kind of do this also, and it's called flow logs. Every network security group has the setting to enable flow logs. If I go back to the Azure portal, in my network security group, almost at the end, it says here NSG flow logs, and you see it's been set up. I can click this and I can select version 1 or version 2. I will always want to select version 2 unless you're using some kind of third-party tool which needs version 1. And I need to select a storage account. So these flow logs, they will be stored in a storage account, which I can just select. And I can select how many days it needs to be retained. And then there's also traffic analytics, which we will look into a little bit later. So these flow logs, they can be set up at any network security group. And once I've set them up, I can use this thing called the network watcher, which you've probably often seen in the Azure portal, but might not really have looked into it. It's a very, very useful thing in Azure, the network watcher. It allows for a lot of different troubleshooting, monitoring, and whatever. It's part of Azure Monitor. In here, I can see which flow logs are enabled and which aren't. So the next thing would be traffic analytics. It's what I've shown before. Traffic analytics uses a log analytic workspace, and what it does is it will take these flow logs and make it ingestible for us. So this is the graph Microsoft gives when talking about traffic analytics. So on the left, we have these flow logs, these NSG logs. They have a lot of different information in it. Every request, every packet in our network is logged in here. So it will be somewhere in the storage account. It will all be aggregated. So duplicate things will be removed, empty data will be removed to reduced logs, which will then be enhanced by other information. So the traffic analytics will take geographical, security information, topology information, and in the end, it will show it in analytics. Now, before we're going to look at how useful it is also good to know something about the pricing. So the traffic analytics itself, you pay for the amount of gigabytes processed. And you can do it at 10-minute or 60 minutes intervals. And as you see, the prices are not that high. It's like 2 or 3 euros. Besides that, you also have to pay for the log analytics workspace and also for the storage account. A lot of this data is not that big depending on the size of your network. So for example, with a log analytics workspace, there is even a free amount you will get before actually you will be billed. I've set this up for some applications and I didn't even reach the amount where I had to pay for it because of we were keeping inside this limit, this free limit. But this can be different depending on how big your organization is, how big the network is. So do keep in mind that these prices, they can kind of scale depending on how much data you have. You might want to split it up or set your retention lower or the processing speed to 60 minutes to make sure that it costs a bit less. I think still the investment you need to do here is not that significant, often based on the total infrastructure cost, and it will give you a lot of information. So let's quickly look at how these flow log looks. So, sorry, this is the wrong one. I want to go to the resource group. So in here we have a storage account. And if I go to the storage browser and I go to blob containers, we can see the log, the network watcher logs in here. And now you see I can go quite deep. Oh, sorry, I took the wrong one. This one, I need the inside logs. So I go deep. Here it shows the different network security groups I have. I can click one, it shows the year, the month, the day, the hour. So you can see when I started to run my lab today, the minutes, the MAC address. And finally here we've got a JSON file, which has all the information in it. If I want to look at this manually, it's not really possible. This is something intended to be looked at by machines, not by humans. Now, if we look at the network watcher, the traffic analytics will be a lot easier to look at. First, let me paint the scene a little bit. I've got a small demo environment where I've got an application gateway linked to a virtual network, which has two web hosts providing a load balanced website. There's a key vault, and the web hosts use some access to this key vault. And I've got a management machine in a different virtual network, which I can use as a jump host to manage these machines. It's a quite simple network. If I go to my traffic analytics and I select the right things here, you can see I can select the time interval. Let's leave it on 24 hours for now. I can say the units, so flow, bytes, or packets. I'll keep it on flows. And here I got a very small overview just showing how many flows there are logged. So you see we have some malicious flows. There's a lot of benign ones. There's some allowed. There's some blocked, I believe. Yes. And here it shows me some visualizations already. The one I like a lot is view subnets. And if I click this, and sorry, this overview, I can't really zoom in that much. When I try, it's getting better nowadays, but the zooming is still sometimes a bit hard. So here it shows some subnets I have. So I have my hosts subnet, the key vault subnet, the clients, and the application gateway subnet. I can move them around a bit if I feel like I want to order them better. So the host is where the virtual machines live with my web server. The key vault is where the key vault lives, the application gateway, and I've got the clients. And you see arrows in between them showing what kind of traffic. So is there actually bidirectional traffic, single directional traffic, and so on. Personally, this overview gives you a lot of information already, especially with bigger networks, because you kind of know how the traffic should go, which gives you a lot of information. So there's a lot of different graphs. I've like traffic distribution, NSG hits, application ports, and also for the different application resources, I can also see some graphs. So for example, here the application gateway. And I can maybe check if there's any malicious traffic. And the same goes, for example, with just the traffic distribution. I can ask for malicious traffic. and see what kind of malicious traffic we have. I can ask for block traffic. So this is quite nice already. Just need to skip this in case the demo doesn't work. And now let's look into detecting some of the mistakes. So one of the first things I can do is I can check the topology. So in the network watcher, I can open the topology view. And I need to select the right subscription. So one moment, this one. And we only want to have this one at the moment. This overview has been changed a lot recently, so I also need to look at it a bit. Because last time I was looking at it, this still looked different, as you can see in the screenshot here. But with this topology view, you can kind of see what's happening. I believe you can expand them and get a overview of what's happening. Well, I already talked about the visualization. And now when we're detecting mistakes, some of the things we can do is, for example, look at some frequent conversations. If I'm not sure if my network is working right, or I want to see what's happening, I can, for example, look at frequent conversations. So here I can say that Bulgaria is talking with one of my clients, which sounds a bit odd. I can, for example, also check the application ports, like which ports are used a lot. And I see here 3389, which is RDP, Remote Desktop Protocol. And I can see the client 1 is talking to server 1, the client 1 is talking to server 2. But I can also see some weird IP address, which is talking to client 1. Not sure if that's intended or not. Maybe it also shows me some malicious traffic. So with malicious traffic, it shows me several different parties which apparently are trying to maybe port scan some of my resources, because these resources are not that secured actually. And there's quite some parties who are just scanning all the known IP addresses from Azure to see if there's any unprotected ports. Now, one thing I like to do a lot is using the NSG to kind of troubleshoot what's going on. Say, for example, I have my virtual machine. So I have this server, and I know this server needs to connect to a key vault. But I don't know exactly if it's using the public endpoint or the private endpoint. Did I do it for server 1? One second, let me find the right NSG. I believe it's server 1. Let me quickly check. Yeah, it's server 2 it was, correct. So this network security group is attached to server 2. It was showing a bit weird in the portal. And what I can do is I can create a rule which uses a service stack. And service stacks are inside Azure. It's a collection of IP addresses managed by Azure. And in this case, it's a collection of all the IP addresses used by the Azure Key Vault public service. So what I did is I created a NSG rule, which says to allow traffic to the Azure Key Vault IP addresses. NSG rules, they work like traditional access control lists. So it will only take the hit of, if it takes a hit, it will stop processing. So if the traffic goes to one of the Azure Key Vault IP addresses, it will stop processing all else, all of the other rules, because this has the priority which is on top. If not, it will check Azure AD outbound, Azure Cloud outbound, and if any of these are, then it will check if it goes to the internet and it will deny it. So this way I can add rules without really interrupting my traffic. Say this rule already existed. Maybe this rule is not, and all the traffic to the internet is permitted. Now in my traffic analytics, I can check for the top rules, and I can see that the rule allow key vault outbound was actually hit by server O2. This rule should only be hit if the traffic actually goes to the public resource. So this way I can easily detect some mistakes. I can also check for blocked traffic to see if traffic which might be expected is blocked. If I want to know even more of it, I can also click see more, and it will actually bring me to more detailed views. And by clicking see more even more, I will go to the Custo query, which is created for me already. I can edit it any way I want and query even more data. So if I'm concerned that maybe something is going wrong, and I was kind of concerned already, because when looking at the visualization here, which takes a few seconds to load, I saw that there was traffic to public IPs from my host subnet, which are my machines hosting my web servers. I could also click on more details here, and I could see there's some 80, some 443 traffic. So there's some HTTP traffic. There might be more. I can look at it. So my machines behind my virtual network, behind my application gateway, they're still connecting to the internet for some things. So this is kind of suspicious. In the network watcher, you can use something called packet captures to do a capture on a specific machine. And when I did this, I saw on my server 2 that it was actually querying the public DNS of Google. Why is this happening? Because probably when somebody was setting up my network, they were very sorry, wrong one. They were concerned, maybe they were troubleshooting something and they forgot to change things back. It's always nice if these interfaces change all the time. So I've gone to the network interface for my server, and you see that the DNS servers are set to custom. So maybe some technician was troubleshooting something and he changed the DNS servers. It could also have been changed in Windows, but you can also change it here. And he forgot to change them back, or they forgot to change them back. And this is why it was using the public endpoint instead of the private endpoint of my key vault, which I saw in my troubleshooting. So that's kind of what I wanted to show you. please consider using these flow logs, these traffic analytics, because it can really help you to get a grip on your networks. I've only shown you some high over stuff now. You can also set up alerts and other things if the flow logs or the traffic analytics shows things which shouldn't happen. Because you can get all the custom queries quite easy, it's quite easy to set up. So if you have any questions, please post them in the chat and we'll look at them. You can find me on the socials with AutoSysOps, and you can find my blog. And thank you for listening. And I think I'll just stop sharing my screen.
Leo, that was excellent. Monitoring is a specialist area of mine, or at least it was for a long time. And I've looked at Network Monitor plenty of times. And as you found in your demo, they've made some of the topology views and some of the additional kind of link through functionality much, much better. So
Yes.
I think there's some really cool stuff in there. Well done. You did really great on that. And you're right. It is always DNS, no matter who says anything otherwise. It always
one
leads
of my
back
other
to
talks.
DNS. So Nick and I had been monitoring the chat on multiple channels on YouTube and LinkedIn and here on StreamYard. So no specific questions other than people just saying hello and all looks good. But
so I've got a question, Leo. So how would people get started with Network Watcher? Like if they have too many, like if it's a complex infrastructure, how would which of the tools would you recommend to use first to download like a troubleshoot?
I would start by just you probably if you have a complex infrastructure, you're using some kind of Azure platform like the well-architected framework from Microsoft. If you're using this, the flow logs and traffic analytics will actually be in there already. The well-architected framework, or I believe the well-architected framework and the cloud framework, cloud adoption framework, both will tell you to do this already. There's also some very interesting policies which are freely available, which you can apply to your infrastructure, and it will set this up for you. So it will set up the flow logs and it will set up these traffic analytics. And just starting by collecting the data would for me be the first step.
Yeah,
and from there
I
you
think
can
you
slowly
can also use like the network flow insights in order to get a better view on where your issue is when you're troubleshooting.
So this is really to take especially this part of the zero trust principle where you assume breach by really monitoring inside your networks to see if something is going wrong. But at the other, it will also help you find any misconfigurations for like public endpoints. See if you accidentally created bigger attack vectors by having stuff being accessible from the internet.
Yeah, it's quite also quite handy because it gave you the custom query already.
Yes.
Some recommendations is quite handy for beginners to like.
Look. And I believe if you want to link it to Sentinel, you also need at least these flow logs, because these flow logs, I believe, can be ingested by Sentinel again.
Okay, good. We got any question, Kevin, for Leo?
No, pretty much. The demo was excellent actually around the Azure networking. One area that we get asked quite a lot when we talk about monitoring network devices, if you like, when in Azure, is how can I monitor my on-prem devices? And obviously the stuff that we've just seen here doesn't do on-prem, right? Because you can't bring those SNMP logs, for example, in just directly, right? You can ingest them in a Log Analytics workspace and then query them. But one thing, there is ways, right? But it's not designed for that, right? So there's always ways that you can chain the data and then use those KQL queries to query it. But one new feature that is coming, again, this is more for anyone else looking at this who's thinking about, how can I use my on-prem monitoring as well as this? SCOM managed instance should be officially announced as GA tomorrow, I would expect, at Microsoft Ignite, which is basically System Center Operations Manager in the cloud. You can put an on-prem gateway server in that on-prem environment, get your SNMP logs in there, pass them up into SCOM Managed Instance, which is a part now of Azure Monitor. And then that opens up the same log analytics workspace where you can query it from there. It won't be perfect, and you won't get that topology view and that additional kind of capacity understanding that you get with the network monitoring and the network connection capability, but it's a good starting point. So just something for anyone that's thinking about that.
Yeah, I also believe, I haven't tested this myself, but I believe if you add the machines to Azure Arc, so your on-premise environment to Azure Arc, you should be able to add a network security group to the network interface when you're extending the network, and then you should be able to also use flow logs, at least on the network interfaces on the
VMs.
The VMs, which are in Azure Arc. But don't pin me down on this. I believe it should work, but I've only read about this, and I'm not sure if I read this that it's coming or that it's already there.
Makes sense. Makes sense. Perfect. So Leo, thank you so much. That was really, really great. And if there's any additional questions, you had your blog.
I'll be in the chat until the end.
In the chat as well. So yeah, but we'll make sure anything else that comes in even after tonight, we'll pass them on to you if you don't see them yourself.
Yes, great.
Thank you so much, Leo. So up next we have Matteo. Matteo, can you hear us okay?
Hello, folks. Loud and clear. Can you hear me okay?
Yes, perfect. And Matteo, I'm going to let you introduce your session on feature flags now, if that's all right.
Thank you, Kevin. Yes, I'm Matteo, and let me just share my screen. So we got something to look at. Screen number 2. So I'm Matteo. I work around at UK Ireland as a director of software engineering, and I'm also a Microsoft MVP for Azure DevOps and GitHub. So I spend a lot of time on these things. I blog about them on the first link on the left-hand side, and if you want to get in touch on Twitter/X, come on, just say hello. If you've got any question, feel free to ask. Now, I'm going to talk about easy feature flags without configuration, and the title is as simple as it gets, really, because so many conversations that I have about good architecture, cloud-native architecture, how to do the right thing when it comes to developing a new app, and how to make sure that you reduce technical debt to a minimum. Everything boils down to this context, to this idea, which is continuous delivery. And usually, if I had an audience in front of me, I would ask, how often do you do continuous delivery? How do you do it for real, or do you just pay lip service to it? Because so many people sometimes just say, yeah, I'm doing continuous delivery, but the reality is that then you're not really doing it, you're not pushing to prod. And that's why the question, how often? Because if you are not doing it often enough, you're not really continuous delivery. If you are doing it with maintenance windows, you're not doing continuous delivery. And that's really important. Like if you're doing continuous delivery, you don't have maintenance windows. It's that simple. And the reason for that is because you should have this process nailed to a T so that you can safely expose new code, new features, new systems, new everything without taking down the whole system. And that's where usually people tend to lose it. Like they say, I do continuous delivery, yes. I do it often. Oh, yeah, we deploy at least once a day, whatever. Fine. How are you doing it? Oh, we have, we got a maintenance window. We pull down all the servers at 11 o'clock at night. We do whatever, and then we put that. That's not continuous delivery. Now, think about it. Right? When you talk about continuous delivery, think about organizations that do it for real. And I'm not going to quote them out of thin air. I'm going to talk about actual data-backed organizations like Amazon. They release 23,000 times per day. Google releases 5,500 times per day. Now, the typical enterprise releases once every 9 to 12 months. And I see them because as a consultant, I go around different types of organizations, different types of clients, and I see them. So don't lie. Don't say you do continuous delivery. You're not doing continuous delivery because the typical enterprise does it every 9 to 12 months. Now, if you are here and you're listening to this session, and I wanted to be provocative on purpose, the question is, how do I get to that? So continuous delivery happens with a concept called feature flags. Feature flags or feature toggles, feature switches, whatever. They're nothing new. It's a concept that's been around for a fair amount of time, and I picked up a screenshot here from Martin Fowler's blog talking about 2017. You can see that over here. So 2017, that's where the idea gets out in the wild. We've been doing it for a long time. Many organizations have been doing it for a long time, and it's a simple idea. You have feature toggles. You have, call them feature toggles, call them feature switches, feature flags, whatever, which will enable and disable parts of your system or the whole system, if you like, which will allow you to contain technical debt, isolate legacy code, make sure that a microservices architecture is a real microservices architecture, because if you flip a part of it off and you isolate some microservices, the system keeps working except for the ones that you isolated, etc. So those concepts has been around for a long time. It's 2023, sorry. How does it look like in practice? There's so many links in this deck, and obviously the deck will be circulated afterwards. But there are different ways of doing feature flags. There is the SaaS way, which is like Launch Darkly. Launch Darkly has got an excellent product for doing feature flags as a service. Absolutely brilliant. I can wholly recommend it. But obviously, it's a third-party, fully managed service, which means that you are essentially externalizing management of your feature flags to someone else, which is all fine. It's absolutely fine. It's using a SaaS product, all good. However, you might want to consider something different. You might want to consider perhaps something that's an IaaS equivalent, where you bring the library, you build everything. And there's so many examples out there of libraries that we can use for feature toggle. So there's always been these two extremes, if you like. You build everything, you pick up your library. Most of them are open source. You pick them up, you build a system from scratch. You have to implement a catalog, you have to implement a database, you have to manage state, you have to do all those things. Or you go to Launch Darkly and you pay a monthly fee. Again, both very good approaches. However, there's now a third option, which is sort of a PaaS equivalent, and it is Azure App Configuration. Why do I believe it's cool? It's an Azure native service, so you own it. Once it runs, you own it, and obviously cost whatever that costs. I don't remember, but we're talking about sort of a negligible cost, really. But the reality of fact is that you can integrate it as part of your architecture without fully externalizing it and considering it a native Azure service, which means that it can become part and parcel of not only your application, but your reference architectures or even your entire engineering organization's standards. That's all with the slides. Let's have a look, right? So Azure App Configuration is nothing more, if we look at it, and we go on, on Azure, on the portal, we'll zoom in a little bit so you can read. It's a service. It's an Azure service. It's got a lot of options, obviously. Most of them you would expect. Some others are very interesting. Like, obviously, you can put a private endpoint, for example, in front of your app configuration store, which means that everything can be fully isolated if you're doing that kind of things. Obviously, encryption is managed. You can connect a key vault to an app configuration, so the app configuration acts as a middle ground, and it just relays the various state for the feature flags. There's so many things, but there are essentially two features. Like, it's two features we're talking about. We're talking about configuration, and we're talking about feature management. Configuration is exactly what you would think it is, right? It's about managing certain key value pairs, and key value pairs can be, in this example, I created this taxonomy of name of application, settings, and name of a setting. It's taken up from the actual Azure documentation, from the actual example. And again, it's something very, very simple. If we start looking at it, we pick up the various keys, and I want to see, okay, how is it? Well, it's something as simple as a string. You can put more things, though. You can put JSON, you can put various, various types of content, which doesn't necessarily mean you're limited to a Boolean pair, essentially. But interestingly enough, you can also connect a key vault. So you can say that your data is stored into a key vault, and that can only exist, that can only be relayed from that key vault. key vault will be locked, and all that. You can tag your settings, which means that you will then be able to group and provide basically different types of segregation for your settings, and look at obviously all the traceability things like an Azure service would tell. Otherwise, the other option is to use features and the feature manager. And again, this is a completely different thing. Here, you're not managing some content. You're not managing information. You are managing behaviors. And that's where it becomes proper feature flag territory. So, for example, here, I just created a beta flag, which is currently enabled. It doesn't do anything, right? Because that's what it looks like when it comes to looking at what the feature flag is. You can have continuously evaluating feature flags, which means that they can be evaluated with time or targeting or other factors, potentially using a custom filter. So you can go on, you can say, okay, I want to target, for example, a time window. So from time X to time Y, this is what's going to happen. Or if it's targeting, I want to have 50% of the user base, for example, receiving this feature flag, and the other 50% will not. It could be by groups. So you can say, okay, a certain group is going to receive my feature flag, a certain group will not. It's a typical A/B testing or business validation testing situations that we often do. This becomes very easy to do because you're using a filter. However, that's all marginally relevant, right? Because what really matters here is how easy it is to use and how integrated it is with Azure. So when it comes to integration with Azure, as I said, it can be Azure replicated, it can scale, and it can be integrated with Entra ID or Azure Active Directory. Brilliant. If you look at how it is supporting encryption, you can see that it's encrypted by default. It uses platform managed keys, and then you can say, okay, this is my customer managed key via managed identity using key vault. Architectures become now slightly different because this is an Azure native service. You can factor that into your design, so it means that you can segregate all of your feature-related information. Now, why is it important? If you're just using it for feature flags, you're just controlling the behaviors, which is all fine, but you're not managing any data. The moment you put in some data in the Configuration Explorer, for example, that becomes really interesting because let's have a look, right? If we look at, we saw background, it said white. If you look at the font color, the font size, and the message. Now, message, this is a good example. It's something that I picked up from the documentation, but I believe it's got a really valuable application. This is data that comes from Azure configuration. That's all it says. It's a message, right? However, this can be paired to certain behaviors. Now, you are essentially parameterizing things. And the interesting bit is everything is controlled by the permutation of features, groups, and rules. So you could potentially expose a VIP section, for example, of your e-commerce, which will feature, let's say, 10% off every price. Has it got to be business logic? Yes, of course. But the actual values used by that logic, they can come from your feature toggle, which means that you can change them very quickly rather than having to change the code. So those kind of things are the simplest possible application of a feature flag and of Configuration Explorer. If you want to go to something different, refactoring. You're picking up a brownfield application, you ring-fence it with a legacy feature flag, and as you refactor, as you make it, as you transform it, as you make it modern, all the new things will go behind different feature flags. Essentially, you are limiting the legacy, you're limiting the old stuff behind a single monolithic toggle because that's how the system was. That's all down to you. And how do you do it? Well, it couldn't be any simpler than that. So if we pick up the code for this application, this is a very simple ASP.NET application, literally .NET new, runs that, and I added a couple of things, which we will see in a second. You see the data comes from my configuration. You can see that the font and the color comes from app configuration. There is a beta page coming from app configuration. Now, this is where things become interesting. How to use this? Well, it could not be any simpler. You add your packages in, right? You add your packages as references. right? Nothing else to do. And essentially, essentially you start connecting to it. You connect to it when you build your configuration. That's what you do. You obviously retrieve the connection string that you need for it. You retrieve it, you select the type of settings that you're interested in this case, and I also selected Sentinel to make sure that if there is a Sentinel key, then, if the register Sentinel key is modified, then the data gets reloaded. So for example, if we change the data in the app configuration, that gets reloaded automatically. And I'm also saying load all the feature flags. That's all I'm doing. On top of that, I add the middlewares that I'm interested in, because obviously I need to add them. I will configure them by saying, give me everything that's got this prefix, and that is all. I don't have to do anything else, because then once I start doing things, then what happens is all in the code. So for example, if I look at the index, you see, it comes from the model, and it's all down to the model that I define. In this case, it's a very simple settings model, nothing special. But the reality is that I don't have to do much. I don't have to code things, because obviously it's like if it was completely parameterized. So the whole thing is now controlled directly from app configuration. Nothing else to do. And it becomes, as I said, it becomes really, really interesting, because the visibility of the beta page, for example, this is the page. Nothing special, right? We saw that. If we go back here, this is the page, this is a website, all right? But let's say, you look at the code, and the code has only got this attribute, feature gate. Nothing else. Now, what if I go and say, okay, I will release that, and I say, I don't need this beta feature anymore. I go into the feature manager, I disable this, it's been disabled. Obviously, this is tyrannic because it's in memory, but if let's say I restart the application, and that's just for the sake of speed, right? Starting the application, create a cache. Obviously, it's always DNS, as I said, as Leo said earlier. Interesting, eh? Did I save it? Because obviously, for a feature flag demo, this is quite topical and quite interesting. So let's also change something else. Just for the sake of demo again, we have the feature manager. This is disabled. All is good. It's loading, at least. Oh, there you go. So change your message, and the beta page is gone. That's how you do feature toggle. It's very, very simple, but it's extremely powerful. Now, let's do something more complex. Let's think about something more complex, right? How do you put this into practice when it comes to DevOps? Well, you don't have to do much, because at the end of the day, if we were to do it, I'm not doing it here, but what do I need to do? Well, you pick up an environment and you say, okay, my environment, whatever, and let's pick up just this environment for the sake of a demo. Then you say, okay, this environment has got certain groups and everything. If I want to put a deployment approval, there you go. I put it in approval, and I can say, fine, this approval happens, and then I can have REST API calls, for example, or as a function that calls my app configuration, and you can do things to the configuration of the code of the application. It's that simple. It's just an API away, so you're no longer restricted. You're no longer restricted to a supply or to a library, for that matter. What you can also do is that once you deploy it, and again, it's all deployed as part of the code, because it's actually, let's look at it from Visual Studio Code. It's more readable. So in the template, this is how you deploy it. So it is an Azure resource, nothing new, nothing different. You can configure it. You can load things. You can load things directly into it or via keyboard, etc. Usual stuff. But it is an Azure resource. That's what it really makes it different. Is there any question? I'm just having a look if there is any question in the chat, because I went very, very quickly, I reckon. No questions. Kevin, Nicholas, any question?
No questions. You clearly explained it perfectly, Matteo. So absolutely fine. Sorry, camera was off there. So far so good. Is there more? Because I'm learning loads from
No,
this.
that would be pretty much it. Like that would be pretty much it. I would like to, if I had any question, I would like to call the questions, because like I didn't want to do the live demo of writing the application up, because it is literally trivial. All you have to do is to run a couple of commands, and you set it up locally. You push it onto Azure. You deploy the resource in Azure. It is connected. Off you go. So the tutorial is as simple as it gets. There's very little value in doing the live demo from scratch. What is interesting, I believe, is that you don't have to do much besides loading the correct middlewares and configuring them up front.
Yeah, I loved and I love the stats that you had at the start, and I read the Phoenix Project. I think it's a great book, right? So you quoted the Phoenix Project about the deployments, and yeah, it's common. I didn't recall the exact stat around 9 to 12 months per deployment, but often when organizations say we're looking for CI/CD, that's kind of what they're thinking about, right? It's not like this super quick every few minutes updating, that would be few and far between from my experience, from what I've seen. But if, regardless, I suppose, of how many deployments, what was the number for Amazon? Was like 22,000, right?
23,000 times a day, yes.
Right.
And obviously that's the North Star, isn't it? Like if you have to pick up a role model, pick up something that's extreme, that's how we usually do in this industry, right? But the interesting situations are, in my view, if you're doing application transformation. Like that's a typical example that I have.
Yep.
I pick up an application. I know it's legacy. I know it's monolithic more often than not. I ring fence it around this feature toggle. Over time, features get rebuilt outside of it, and they get built in a different architecture. For example, moving from monolith to microservice. Each microservice can be isolated. Each business feature can be isolated, and it will basically enforce good architectural practices, because it will force you to think down that path of everything must be isolated. It's like a breaker panel at home, essentially. If you have your light circuit, you have your room circuit, you have your high absorption circuit, all of this. It's a very, very similar approach, but for code.
Matteo, I've got a question from Leo.
Go for it.
He asks, how does feature flags look like? How does feature flag lifecycle look like? Would they eventually be removed from the code or Azure, or do you have to manually remove it?
It depends. And again, I sound like a consultant because essentially that's what I am, but it depends, right? So you will have a feature flags that will disappear in case of the legacy feature flag that encapsulates the application and things get extracted. So that will die down at some point. There will be other feature flags that will always exist as a stopgap, for example, typical kill switch that you might need on an application. You will have feature flags that you can use. And again, we saw briefly an example. Let me get back to it. So in this situation here, where you have exposure controlling your features. So if you go to the Configuration Explorer and we say, okay, I want to have a certain configuration item, and then I want to pair that up with a certain feature toggle. This feature toggle will have a feature filter, which is connected to groups. So I might say, these groups will receive a certain version of my application. These other group will receive another version of my application, or another version of a feature, or a microservice, or a system, whatever that is, right? Or even by user, potentially, but it's a bit, I would never recommend using users, to be honest.
Okay. So
So you can say, okay,
I take it the groups will be one way to like
yeah,
feature flags.
yeah, and then you end up in a situation where you say, okay, group A has got 50%, group B has got 50%. Typical A/B testing, right? Which is the one that works? Users from group A will receive a certain version. Users from group B will receive another version. Evaluate. That's what happens afterwards. And that's what you usually do if you're testing something out as a minimum viable product. You want immediate feedback. The moment you start diverging and you start adding more, you need scale, you do A/B testing so you can see which is the one that sticks. And then over time, these will go down, for example, to 80-20, and over time, one will disappear. It's important to have good hygiene of feature toggles because otherwise there's a risk of accumulating technical debt on that. And the Knife Capital example, unfortunately, it is the lighthouse moment where a company essentially went out of business because of a feature toggle that was reused. So it's very important to maintain good hygiene and good control over feature flags.
Yeah. And I take it that percentage, it's just experiment, right, to get the right percentage you need.
Yeah.
You just have to.
Yeah. This is down to you, right? This is down to you. This can be group A and group B, or it could be, in the case of e-commerce, it could be VIPs and regular users, right? So you say, okay, regular users could be something like this. So that in this case, it would be probably the other way around, where the VIPs will receive 10% of this feature, or even like this. You say, okay, this feature, this is reserved for VIPs. VIPs will always receive it. Regular users will never receive it.
Okay. Yeah, I get it. If you were to give like this feature to like a developers or stuff, I take you just give them the code and they turn it on and turn it off if you want.
Yeah. So the feature, the way you access a feature, if I go back to the demo, you obviously configure app configuration and you say, okay, use feature flags with no label in this case. You could add a label and say only use a certain type of a certain type of label for it, but there's no point in reality. So you pick that up, you say, okay, use feature management, and then features, for example, in Razor, get exposed like this.
Okay.
If you want to do it in code, you just call the service.
Yeah.
The service will give you if the feature is enabled or not, and there you go.
Okay. Yeah, quite interesting.
Very. And I believe app configuration makes it extremely easy because Launch Darkly is SaaS, so it's even easier. But obviously, it obstructs a lot. So you're using a third-party service. Fine. Using a library means that you have to build your own configuration database. You have to maintain the states. You have to make sure that it's secure, backed up, etc. It takes a lot of effort. This is literally turnkey. Plug and play as it comes.
I take it you explained this before in a project already, right, Matteo?
Yes.
And it's better than actually third-party feature flags from launch.
Well, in terms of better, I use both Launch Darkly and Azure App Configurations extensively, as well as obviously some of the libraries. Launch Darkly is brilliant when it comes to ease of use.
Yeah.
And I recommend it, especially if you have a small scope or you want to get started in a very quick way, especially with things that might need a lot of rework. It works really well. Like all you have to do with Launch Darkly is obviously register on the website, get an account created, get everything set up. You receive a key. That key is going to be used for identifying your user, which obviously is not the named user. Shouldn't be a named user, at least at the beginning. And then you can start building and you can start segmenting. These requires a little bit more because obviously you need to maintain the life cycle of app configuration. It's an Azure resource. It's got all the architectural configurations, private endpoint, G distribution, etc. but at the same time, if launch darkly is 100% easy, app configuration is 90% easy. A feature, a feature flag library is 10% easy, if you ask me.
Yeah.
Matteo, Leo has a question. I'm just going to read it out. I don't know if he's still online.
Please.
So feature flags are queried via the internet. Are they vulnerable for things like DNS cache poisoning? And if so, how big of a risk do you think that is? Is there a mitigation for it?
Obviously, it's always DNS, Leo. So you saw the demo. You saw the demo where my DNS cache was still storing the feature flag, and obviously I restarted the application. It took a little while, etc. Now that was obviously all static. However, yes, everything happens. Well, everything happens. By default, it happens on the public internet. So you have to take the same consideration as you would with any other Azure resource, right? So the first thing that you do is, rather than going with a public endpoint, you pick up a private endpoint. You put a private endpoint into it, and then off you go, right? You add the private endpoint. Everything is only accessible via private endpoint. You treat it like you would a Key Vault, a storage account, etc. That will be the first thing you have to do in the real world. Then, obviously, if you want to add your own encryption key, you go with CMK. You connect the Key Vault with a managed identity, and you can add that as well. So you also own the key. There's not a lot more that you need to do. Because at that point, especially if you start, then you pick up this and you say, okay, all my configuration file, all my configuration values, they come from Key Vault. This becomes a proxy that only serves values based on some logic and the features of app configuration, but it's just serving data that comes from a Key Vault. So if the Key Vault has got CNK, you've got a CNK on app configuration and private endpoints galore, it's as secure as it gets.
Leo, can you come off mute and let Matteo know if that resolved your problem or answered your question, if you can?
Yes, of course. Thanks for the answer. I think that answers my question. Yes.
Awesome. Everybody's learning today.
Yeah.
Super. And again, sorry for being that quick, because this is usually a more interactive session, to be honest. But again, that's the type of questions that I like to entertain, because the system itself is very simple. The demo is even simpler, but there's a lot to unpack, and those things only come out when you start articulating, because otherwise I can show you all the features, but then you will have even more questions and you don't have time.
Yeah.
I think it also aligns, like my background is IT pro, right? So we're doing DevOps, but I wouldn't class myself as anywhere near a DevOps ninja. But
you can't see what's underneath here because there's my name and the Twitter account on it, but there's a 12 units rack cabinet there, and it used to run several servers, hundreds of VMs for my lab. Obviously, over time, moved to the cloud, the lab went down, and it became smaller and smaller and smaller. But yes, I get the background, and I was there when so many years ago I was considered part of infrastructure, IT pro organizations, but I was the one writing C# and I was the one building pipelines because I loved ALM. Even before we were talking about DevOps, I was already doing it, and I went then on stage in 2012 talking about DevOps. So yeah, I've been in that camp.
Awesome. Really great now from my perspective. Some really interesting features there.
Yeah.
Super.
Cool. I don't see any more questions. Let me just do a quick check. No, I don't see any more. And Nick and Leo, if you guys don't have any more, I think we can wrap it up.
Yeah. Okay. Thanks for joining, Matteo and Leo. Good presentation.
It was a pleasure.
Yeah.
Thank you, guys.
That was brilliant. Thank you so much.
Cheers. Goodbye.
Bye.